Okay, good day, everyone. I'm so happy to be here as today we're talking all about the confidential computing with quite a nice and good topic. My name is Roman. I'm principal architect and I'm leading security community engagement at Red Hat. I also maintainer and contributor to open source and just try to make sure the security is reasonable and engineering centric in software development in general and in open source specifically. Today I have extremely small amount of time, 15 minutes, to talk about how to build confidential computing on an open source stack. All right, let's keep it going. First of all, as we enter in 2026, I think it's very, very important to mention that the world is changing and priorities are changing. If you would please have a look at the recent cloud security report by Red Hat, where 96% of respondents said they have worries about the use of Gen AI in their cloud environments. On the other hand, 60% of companies surveyed have no AI governance at all. Quite scary, isn't it? Also, things like DORA, the EU regulation for financial entities and digital sovereignty, which actually goes beyond Europe in other regions as well. And also, we see the increasing amount of distributed AI training and remote AI inference, and etc. So that all makes us pretty confident to say confidential computing is at rescue, right? This is the recent IDC's confidential computing study in, I think it conducted last year, yes. And if you can see 75 overall, 75% of the respondents said that they either deployed it in production or piloting or testing use, which is quite a significant number, which brings us to understanding that we are switching over from the education and from the niche application of confidential computing to a real production deployment as we get in value of it. I don't have that much time to explain how it all works, but in general, it is for rescue confidential computing based on trusted execution environments that protects in-memory data from unauthorized entities. Basically, the four pillars or the four defining characteristics of TEs are memory encryption, isolation, remote attestation, and data integrity. But if you have a look on this picture, which is on the right-hand side, you can see that something is missing here. And of course, the TE are based on the hardware, right? On the hardware that should support execution of the workloads inside the secure enclave. But for today, with this presentation, I will try to show you how open source can actually help navigate this. And also I have a bonus slide about the open source hardware as well. I think that what you do should not dictate where or how you do it. This is our paradigm here at Red Hat, but I think it reflects across the industry. We want to have flexibility, but we want to have control on the other hand. So open source can help with all of this. And even with such relatively complicated technology as a confidential computing, open source enables the wide adoption of it. What are those key confidential computing communities? I would point out to three of them and others. Confidential Computing Consortium is a great avenue where we discuss all things confidential computing, define the standards, at least try to, and most importantly, encourage all of the vendors, both hardware and software vendors, to collaborate together to make sure confidential computing is standardized, accessible, and seamless for everybody. CNCF also have a good handle on the confidential computing, mostly with the confidential container project, which I will explain in details later on. And also there is a trusted computing group, which defines specifications mainly related to TPMs, trusted platform models, and measured boot processes. Of course, we have other communities that are somehow connected to confidential computing as well, like KEMU, libvirt, Lux, Linux kernel itself, and etc., etc. So those projects are instrumental in enabling confidential computing at scale. There are three main models of confidential computing based on who you trust or kind of trust boundaries: confidential VM, confidential containers, and even more confidential clusters. For the purpose of this presentation, I will focus on confidential containers as one of the easiest way to build confidential computing capabilities for hybrid cloud environments. And of course, we're more than happy to have you on board. Please join us in all of these communities, as we really true value your feedback and contribution, and we couldn't have achieved the current level of maturity of confidential computing open source stack if there were no contributions. Please join us. We're really friendly and we don't bite. Now, I promised you to focus on confidential containers. Today, first, I want to start with how do I create a TEE, trusted execution environment, using open source. And those three projects, KEMU, Kata Containers, and Confidential Containers, can help you on this. Kata Containers is an open source community working to build a secure container runtime with the very light virtual machines. Don't be confused and don't be scared that we kind of spinning off the virtual machine instead of containers. It really sounds like an actual container, but on the other hand, it provides stronger workload isolation by utilizing hardware virtualization as a second layer. Kata Container supports multiple hypervisors, including we call them type 2 hypervisors like KEMU, for example, and also type 1 hypervisors like KVM, and integrates with Containerd project among multiple others. Now, how do I actually utilize these projects to build the confidential VMs and confidential containers? This is the simplified picture that represents how it could be done by using confidential containers or COCO project. Kata containers actually can use a single configuration file which contains everything, including the runtime, agent, and hypervisor configurations, and it acts as a runtime to manage container lifecycle within a specialized virtual machine, while KEMU acts as a local hypervisor. The COCO project, in general, aims to enable users to run containers inside trusted execution environments that are, powered in this particular example by containers on any Kubernetes cluster. And this is where I was referring to the flexibility, because when it comes to hybrid cloud environments, we don't want to have the limitations. We want to work it all across the hybrid fleet and independent of the vendor, independent of the installation. And COCO provides a common foundation for deploying containers inside VM or process-based TEEs. So now, once we built the confidential containers, right, using the confidential VMs, then the other part of the confidential computing is remote attestation. How can I trust a TEE using also open source projects? And I want to bring in two great open source projects here on the page. The Keylime, which supports runtime attestation, and it has integrations with the kernel's integrity management architecture. Basically, that is, or typically Keylime is used for remote boot attestations for TPM-based systems, or for like more flexible cases when you wanted to do something on your own and get more control over the operating system and the whole environment. Confidential containers trustee project, on contrary, optimized to act as an admission gate, and it seamlessly integrates into the containers and Kubernetes ecosystem. So all the links are here. I will not repeat the links on the following slides, but of course you can then access the slides and learn more about this. Now, how confidential computing attestation works with trustee. The left side of this diagram includes the guest components running inside the TEE, including the attestation agent and confidential data hub. The right side includes the external components which the guests such as, for example, key broker service, attestation service, and the reference value provider service. We only have actually so low amount of time, but all of these acronyms actually maps to ETF RATS, Remote Attestation Procedures Architecture, and this is very important that trusty open source remote attestation tool maps to these standards to make it true confidential computing compatible. If we look at the full picture and how we can scale the deployment, on the left-hand side, you can see the hub cluster managing security, and it can contain the trustee, right, attestation service and key brokers service all in one, or actually they could be split based on the type how you deployed trustee, but for the simplification, they could be there. It can provide the reference values between the trusted infrastructure, and then when you run clusters that carry workloads, the confidential containers, even on untrusted infrastructure, it can ask attestation service and KBS for the evidence and for the attestation. It's very important to mention that for container VMs, there are a lot of restrictions still, and a lot of the security considerations that should be taken in account. For example, when it comes to how operating system image is handled, we must make sure that the CVM host, storage provider, or anyone else basically outside the TEE environment from compromising the image, because otherwise, imagine it could be easily compromised and tampered. There are a lot of other security considerations related to CVMs specifically. Don't want to dive into the details that much, but I want to leave you with the understanding that confidential containers consistency can make actually measurements achievable as the part of the resolving some of the security consideration that I mentioned before, like preventing tampering of confidential VM OS image, right? You can learn more about Coco use cases on the official website. Again, this is all free, open source, contributions are welcome. You can ask me a question, wait, is it really so hard to deploy? I would offer you the answer, no, it's not really hard to deploy, because when we talk within the community and also within the industry, typically it's relatively hard to explain what confidential computing means to the average person, but it is significantly simpler actually to deploy confidential computing, confidential containers specifically. There are so-called confidential containers or COCO validated patterns, also available at GitHub. And these validated patterns can use Kubernetes cluster, for example, open source OKD, and well integrates with the CI/CD tools like Argo CD that can help you to spin up applications, so that you can then utilize Open Cluster Manager, for example, for Kubernetes environment. And as I mentioned previously, Trusty and KMS, I mentioned that briefly, but key management storage is of course required as you kind of manage the keys or store the keys for Trusty. And then on the right-hand side, remember the previous picture, right? The left-hand side, data center hub, the right-hand side, spoke or edge, the actual workloads. We can also utilize open source OCM agent and use Argo CD and Kata containers to run confidential applications on it. The icing on the cake that you can use these validated patterns as the almost a one click. This is all the instructions over there, so it's relatively easily deployable, which is good and justifies to the easier adoption of the technology. Finally, to wrap it up, I mentioned these hardware vendors, CPU vendors that we still rely on to actually execute, to support TE and to execute confidential workloads in the enclaves. But there are a number of the paper and research and researchers that are happening in the RISC-V community and also in the ARM related community. I just returned from FOSDEM, which is annual open source gathering in Brussels, Belgium, and there was the full dev room, like mini conference about the confidential computing, and there are a lot of interesting researchers who are presented about how open source can be leveraged to enable or to unblock confidential computing implementations, both from low level to the confidential containers, like more cloud level. So that's been said. Hopefully, we will see one day when we can say truly that confidential computing stack could be built fully 100% on open source, which would be the dream, I think. But now, join us in building secure future for all open source way. Join the communities that I just mentioned, and don't hesitate to try it out following the links that I shared. I'm going to stop here. Thanks very much for your attention.
Thank you, Roman. Sorry for that rough start. I had like catastrophic failure across many different things, so I really appreciate your taking the baton forward. That was a really good overview, and of course, I am a super fan of open source, so I really appreciate you coming in and kicking us off.
Thank you. It was my pleasure.